When it comes to troubleshooting caustics, it can feel really complicated and difficult. So today we're going to be going through how to set up your caustics, whether if you are working on a client project or a personal project. We'll go through all of the settings. So this is an advanced tutorial. We've had a couple beginner level tutorials going through 3D modeling while using caustics and setting that up in a very rough preliminary way, but today we're doing a deep dive so that you feel like you can troubleshoot any problem you come about while rendering with caustics. So let's go ahead and jump into Cinema 4D and Redshift and get rendering. If you find any of this helpful, please remember to hit like and subscribe because it helps me continue teaching and helping people learn Cinema 4D like you, and you're awesome for being here. Let's get started. A quick review of last week. We had talked about how to create vases like this, and this is the rendering sample of them. And then we 3D modeled one ourselves right over here. And if you were to look at this and I hit start IPR, you can see that we do have some caustics in this scene, but they aren't quite as detailed. So in this tutorial, I really want to go into the advanced settings and talk about how to troubleshoot caustics and get them looking exactly the way you visualize, and the different engines in which you can render these caustics in. So if I were to open up my render settings, you'll see this here. And we can even click on Redshift, but you'll notice that we have these two different modes. You won't see any options here for your basic mode. In your advanced, you'll see your caustics options. So if you want to see these, you're going to need to turn on your caustics here in your advanced. And make sure that it's enabled. Here you can turn it on and off. Here you can select your render engine, brute force, or photon. And both of these have strengths and weaknesses. And if you understand the strengths and weaknesses of each one, you can decide what makes the most sense for your project, whether if it's this vase, a personal project, or something you're doing for a client. And this is really important to understand. And I don't see too many people covering this, so I'm going to go through all the settings today for both, and you can choose what makes sense for you. So brute force, this one is really good at handling indirect lighting. We're talking global illumination. If you have a material that is illuminating and it's illuminating other objects in your scene, you want this brute force probably because it'll be a better fit for that. Now, something to keep in mind about if you are using caustics with brute force is that it's a little bit more complicated to set up your sampling because you actually need to turn off your automatic sampling. And your automatic sampling, by the way, this determines how many calculations, how many samples. You can think of a light ray bouncing. How many calculations are happening in your scene for various factors? Like if I turn this off, you'll be able to see these in the overrides. How many samples per calculating reflection? How many samples for refraction? How many samples for ambient occlusion, light, volume, subsurface single scattering, subsurface multiple scattering? So it's really, I feel like, a more advanced thing to know how to set this up manually. But once you do that and you set up your samples for your scene, we're not going to do a deep dive of that here today because otherwise this tutorial is going to take a very, very long time. And I feel like talking about all of these is a whole other topic. I'm focusing here on caustics today. So if you turn that off, you'll see in your caustics under brute force that your brute force rays become available. So now here's where you can increase how many rays you need, how many calculations you need to clean up this render that you're doing with brute force. You'll notice that if I have the automatic sampling turned on, we don't have access to that because Cinema 4D is automatically calculating it. But chances are, in many cases, if you're working with the brute force, you may want more rays for calculating it to get a little bit more defined look to your caustics on the surface. So it really depends on your lighting and your situation, but you may want more, and then that means you need to set up your sampling manually, and that does take more time. Now, the nice thing about the Photon is that the Photon allows you to use this automatic sampling while also adjusting the number of photons or calculations you can think of it, the bounces. Photons are a light particle, and Cinema 4D's way of calculating that light particle going through space and bouncing off of surfaces. So that is this here, your number of photons. It's very similar to the rays. They're just slightly different names because they're two different engines for the caustics, but similar idea of a light ray is going through the scene and being calculated, bouncing in order to simulate caustics. A light particle. Okay, so that's that. And going back to pros and cons of both of these, a con is probably the brute force takes a little bit more time to set up, although it has fewer settings for it. You can really see the difference here. You can turn on indirect caustics for your brute force. That's the one setting for your brute force besides the number of rays when you turn off the automatic sampling. The Photon has many, many more settings in here, but it can handle direct lighting very well. It doesn't handle the global illumination as well as the brute force. In my experience, it tends to render quicker with less noise than the brute force, so that is a benefit of the Photon, is maybe it's a little bit less realistic than the brute force, but it renders quicker with less noise. So that's definitely a benefit there because calculation time can be very important to you. And for the Photon, different types of lighting work well with these. So for the Photon, if you go into your lighting, your point light is going to work great with this. Your spotlight is going to work great with this. Infinite light is going to work great with this. If you were to use a Redshift Sun and Sky, this will work great with your Photon. Your Redshift Sun and Sky is not going to work well with brute force. Brute force works well with something like a dome light. It works well with some area lights. We're going to talk about that a little bit more in depth in a moment, because overall the thing you need to remember is that Photon works well with small direct lighting. Brute force works well with indirect lighting, large lights. The larger the lights, the better it renders. So Photon works better with narrow lights. And as far as compositing goes, Photon does offer you more options with compositing when it comes to AOVs. So what are AOVs? That's a whole other topic in here. We have this tab called AOV. Now you could render out an image without individual layers to composite in post like this. What we had rendered out for our project, we had rendered out, I think we had rendered out the scene in the last one, and you can see this is one layer, one beauty pass, one image. You can have multiple layers. You can separate out your caustics. You can separate out your diffuse lighting, your reflections, your refractions. You can separate all of that and then composite it together into one image and post in a software like After Effects or another one of your choosing using AOVs. So the thing to keep in mind is photons will show up in your caustics layer. If you use brute force, this will not work with your caustics layer, your caustics AOV. You can find your caustics actually in your global illumination layer if you were to use brute force. However, brute force does not separate your global illumination and your caustics. They're all in one AOV together. So if that's something that you want to edit separately from your global illumination, your other indirect lighting, then a photon would be a better choice for you. It really depends. So that's something to keep in mind. Photon's better for compositing in post if that's something you enjoy. I tend to like to just render out one big beauty pass instead of a bunch of passes, because AOV passes, because the AOV passes take up a lot of storage on my computer, and I'd rather just render out one. And it's very rare that a client will ask me to adjust a single highlight somewhere, and I'll need to dig into just that one layer to change it. But you decide what's best for you and what you're doing. It may be different than me. And so let's talk about this. And this is going to be fun because we're going to get rendering. So in here, I'm going to hit Start IPR, and we're going to do a deep dive into what these settings do. Super pumped up about this. Okay, so we got this going. We got this rendering. And we can do so much better. We can do so much better. So right now we're rendering with photons. So what we know about photons is that they work better with narrow light. So right now we have this light over here that's pointed towards our vase. I click the middle mouse button to see all 4 views, just so you can see where our lighting is relative to the vase. Okay. So considering that we're using photons, how do we make this area light narrower so that it works better with the photons? Well, what we do as we go into the Object tab of our Redshift light, we scroll down here, you'll see this option called Spread. This controls how narrow the light is, how much it's directed at the object. So right now it's pretty wide, it's a little bit more diffuse, it's got the spread all the way open. Let's see what happens when we take this down. It becomes closer to a spotlight. And that tends to do better with photons. Now you'll notice that since this light is a little bit more directed, it looks a lot brighter. So I'm actually going to adjust the intensity here to something like 2. See how that looks. So that's looking a little bit better. I also want to change the color of the light to temperature so that we're using lighting temperature as you normally would in real life. And then maybe I want to take this down a little bit so it's a slightly warmer light, so this feels nice and cozy. Our image over here. Maybe we want to try 4500 and see how that's looking. Okay, so we have this nice warmer light in here, and we've adjusted the spread a little bit and adjusted the intensity. And you can, of course, play around with this even more. And already, I think it's starting to look better. Now, when you're rendering, if you want to see something closer to the final version, you can turn on this bucket mode. This is good for previewing, but the bucket mode is better for seeing what it'll actually look like. So I'll turn on the bucket mode under the Redshift. And in our render settings, you'll see that we have these global overrides. Now is a great opportunity to start talking about what these global overrides do. And this will be super fun. So you can see something funny happen. Since our image was so noisy and we have the denoise on, it made these squiggly marks on here. So if you're seeing those, that's what that is. So let's go ahead and turn off our denoise. You'll see that under sampling, and I'll actually turn on automatic sampling again in here. And I'm going to turn off denoise. So now Cinema 4D is automatically calculating our sampling, which works well with photons as we discussed earlier. And we turned off the denoise so that you can see how the noise is being affected here a little bit more clearly. So you can see we have a fair amount of noise in here, but that's okay because we can make further adjustments. And something that I'd like to show you right now is one way to clean up a render like this is actually by adjusting the number of photons. So right now we have 100,000 photons. So if we throw more photons at this, it will start to clean this up a little bit more. So I'm going to increase this to 300,000 and let it go. And you'll see that this does improve when I hit refresh. So you can see that that's a little bit less noise. There's still definitely noise in here. But I do want to go over some of the other settings first before we do a deep dive in all of that. So the next thing that I'd like to discuss is the difference between reflection caustics and refraction caustics. So refraction caustics are the caustics going through transparent objects like glass and water or wine. Reflection caustics are from shiny materials. So let's actually simulate that. I'm going to drop a cube into the scene. And I'm going to turn off the bucket mode just for a little bit to make this easier for you to see more quickly. I'm going to move over the cube, going to scale it down, something like that. We have a cube in our scene. Right now it's not reflective, so we aren't seeing very many reflective caustics on it. So let's create a reflective material. I'm just going to say create a material, open PBR, so that you can see the difference between these two options. I'm going to increase the metalness all the way, reduce the roughness all the way. You can see it's a shiny metal. Drop this onto the cube, and we have caustics happening not just on glass, but on reflective materials. So right now you can see if I turn off reflection caustics, these caustics around the cube, they're going to go away. So I'm going to do that just so you can see what they are. Oh, I clicked on the wrong one. Reflection caustics. Okay, so you can see that those really interesting highlights on the floor, those caustics from the cube itself went away. And these are the global overrides, so you can actually control these individually on different lights and objects. So you can control which ones have reflection caustics, which ones have refraction caustics. You can control which lights are casting caustics. With tags and other settings, we'll talk about that. Disable intensity clamp. That controls if you allow the render to clean up further beyond the amount of samples allotted, it'll allow it to clean up further the caustics in your render without clamping them down based on the sampling. So that can be really nice for reducing noise to leave that on. And by the way, these global overrides are available for both brute force and photon. So let's discuss now how to operate these overrides on individual objects. Let's start off with this light over here that we were experimenting with. So this light, if we go into our details and go all the way down, you'll see this option called Caustic. So we're in the Detail tab of our Redshift area light. You can choose to control the caustics. You can choose to turn them off, so this light is no longer affecting caustics. You can see that shifted in here. You can see the caustics are gone since we turned them off on this individual light. Or we can choose to use the render settings in which they are on currently. So we'll turn that on. You can see the caustics reappear. And we can also choose to just turn them on manually and override whatever we have in the render settings. We can override it in here. Now I'm going to show you how to override the reflection caustics and the refraction caustics using something called a Redshift tag. So if I wanted to override that on something like this glass here, I can right click on here, go down to my render tags, and add in a Redshift object. Now this lets me override some of the render settings in here for a Redshift for this individual object. Under our visibility tab, I'm going to click override and enable that in here. With this enabled, we can choose to turn on and off cast reflection caustics, cast refraction caustics. Here, you can turn them on and off manually in here. So that's how you adjust that. And one more thing that I'd like to mention about this Redshift area light, in case if you'd like to adjust this further, is the intensity and the photon multiplier. If you want to increase your photons more for this light than other lights in here, well, you can multiply it. You can increase this number and it'll clean up a little bit more. So let's say we really want this light to look nice and clean. We can turn up that photon multiplier. You can also increase the intensity, so that'll increase the intensity of the caustics. Now for this area light, maybe we don't want this light to affect caustics. In that case, we can turn this off. So you really have a lot of control over what lights are affecting your caustics, which ones are not in your scene. You can use the global overrides, but you can also manually adjust these per object. Okay, so now we're getting into the photon settings. There's a whole lot more in here to know. You have these different modes in here. We have rebuild, load, rebuild, pre-pass only, rebuild, don't save. What are these talking about? Well, rebuild, don't save. When you render out your project, it's going to calculate the caustics each frame without saving them to a separate file. Let's say we wanted to rebuild and save it somewhere. So we are rebuilding and rendering out each frame with this rebuild option. And in this case, you can see that the file option becomes available and we can choose a location. Like I can choose, I'm going to render my photon maps in here. And you can see I already have one in here from when I was testing this out before this tutorial, but you could add them in here. So maybe I will actually add these in here. I'm going to save so that we're saying that's our save location in case if we want to render this out. Load will allow you to load one of your saved files of your photon calculations. There's also an option to just do the calculations without rendering out each frame. So what that means is that you're going to be saving a file in here, your cached calculation, but you aren't actually rendering out the final render. You're just leaving it there for your future self. You can think of it and compare it to something like doing all the prep work for dinner. You're chopping up the vegetables, they're ready to go, but you're not quite ready to cook yet and have a final product, a final meal. So you're just chopping to prepare to cook dinner for later. So you put the vegetables in the refrigerator chopped, knowing that'll make it easier to cook dinner later. That's basically what this is. If we want to give a nerdier example of this, It's similar to caching out pyro simulations. You can cache out a simulation of a fire before you render it so that you can have those calculations available so that you don't have to wait for them each time. If you want to have that fire in multiple scenes or render it multiple times at different angles, it can be a time saver to do that. So maybe one of those analogies works for you. It depends on your experience and your background, but I figure the prep and the veggies, everybody's done that before. Hopefully you guys have cooked before. And yeah, so those are your modes up here for your photons. It's kind of nice that that's there for an option. It's like caching out your photons. And we talked about the number of photons. It cleans up the render more if those are on. I'm going to actually delete this Redshift tag because I'm okay with using these global overrides, actually, I think. I don't feel like I need them in here for that object. And let's talk about the max photon density. So your max photon density. So the max photon density is the max photons that can be stored for your blur radius. Your blur radius blurs out your caustics in order to make them look smoother and less noisy, less splotchy, and all of that. So we're going to show an example of that. I'm going to hide this cube because I feel like I'd prefer to not use it for this example. And I'm also going to turn off the secondary light because I want to make the caustics a little bit more clear for this. I may, with that, increase the intensity of this light. So do that ever so slightly here. Or I could even narrow this in a little bit more, this spread. Something like that. Okay, so now we have this here. I'm going to go into my render settings and I'm going to choose an output location where to save it in here. Vase render caustics version 01. I'll do that, and then I'm going to hit render and probably save this perspective by adding in a camera and clicking on it. And then I'll hit render and I'll say render all in overwrite. You can see that I was doing some earlier samples in here. So I'm going to remove those because right now we're focusing here on this one. So right now you can see that this is what it looks like if in our settings we have rebuild prepass only. So you can see that it did the prepass and you can see that saved in here, but it didn't finish rendering out the full frame. The current frame we have set for the render. So if in our Caustics tab we also want to render it, let's choose rebuild in here and then hit render, and it'll not only do that prepass but the full render. So I've done several renders, adjusting little settings between them so that you can compare things like the blur radius, different resolutions and how they affect caustics, and how intensity affects caustics, how the photon multiplier affects caustics, and all of that. So let's take a look in here. You can see this is where I ended up, but we start off here. So we're going to start talking about a little bit of troubleshooting and what you see within your render and how to fix it using the photon renderer. So this one here, you can see that it looks pretty grainy. So my intuition told me we need to increase the number of photons, and sometimes that helps. It really depends on the light. It depends on a lot of factors, but we increased the photons from 300,000 to 600,000 for this in here. And once again, you can find those in your caustic settings. That's this number of photons. We increased it from 300,000 to 600,000 in this render. Okay, so then that wasn't enough. So what helps photons render caustics better is usually making the light a little bit narrower. So we did that in here. We narrowed the light. Now the problem with narrowing a light is that it pushes that light into a smaller space, so it makes it even brighter. So it was way too bright. This is totally overblown. So then in the next one, I took down the intensity a little bit. It's still a little bit grainy, but we're getting some interesting effects here. You can see on the floor, we're getting some very interesting caustics going both this direction and this direction. We have some grain, some fireflies, so it still needs some work. So I want to see, well, what happens if we blur this out a little bit to hide the grain? So I increased the blur radius in order to decrease the grain, and you'll see that here. I increased the blur radius from the default to a whole 1, and that really blurred this out to the point where I felt like, I don't like how much detail we've lost in here. That pattern in the last one was pretty interesting, and then it's gone. So then in the next one, I decreased the blur radius to 0.3. So that did remove some of the grain. It still has some grain. So here in this next one, I increased this to 1 million photons. So we've really increased this quite a bit. It's getting closer to looking nice. It's getting there. And then for this next one, I did a subtle change of increasing the photon multiplier within the light itself. So when I'm talking about that, I'm talking about this in here. When you click on your light, under your details, photon multiplier, you can see that this increased. So that did make a little bit of a difference in here. But it wasn't enough. So what do we do after that? Well, I tried increasing the intensity a little bit because I wanted to get more of this pattern to show up a little bit more clearly. So I increased the intensity, and again, within our light, the caustics under intensity, I increased this from 1 to 2. So you can see that difference between the intensity lowered and the intensity higher. So now you can visually see what these settings are doing in here as we troubleshoot and adjust things and get this looking a way that we like. And you don't even have to wait for it all to render, because I did. And yeah, we can just keep going. So this one, from 10 to 11, I have that I increased the blur radius from 0.3 to 5. And you can see that really got rid of a lot of grain, but it didn't feel right. We were losing some detail. So at this point, I wanted to show you a little bit of something different, because it is a little bit easier to get more detail in a render if you increase the resolution. So this was in HD, and I increased this to 4K. So if you aren't super familiar with what's 4K, this is the 4K 3840 by 2160. You can see that difference there between these two, and see what that looks like in terms of a difference. And then on this last one, I kept it in 4K. And the change that we made between these two was I reduced the spread from 0.023 spread. And again, the spread is under your object tab of your area light. And you can see it's right down here, 0.1. That's how narrow the light is. So that was what I did. And then I also reduced the intensity to 0.8, because we talked about when you reduce the spread, the intensity becomes more. So I took this down from 1 of intensity to 0.8 of intensity. and this is where we landed. So this is for the photon rendering. There's a lot more settings you can adjust with the photon rendering, so you can really see that a lot here. When it comes to brute force, you really are just brute forcing it, throwing more rays at it, I feel like, and increasing the light size to adjust the render speed as well as the amount of detail. In the photons, you have options like adjusting the blur radius and such like that. But I do want you to compare this render that I've done with the photon renderer engine to what I had done with the brute force renderer engine. So that's actually the thumbnail. I think I can pull up something better here. So you can see this is the brute force render engine. So you really do get those finer details, but it's a little bit more work to set this up, as I said, because you need to adjust your samples. There are fewer settings. This is really just relying purely on physics to get these calculations looking just right. But if you use the photons, you can get something pretty close in maybe less time, and sometimes that's good enough. So I wanted you to see a comparison of those two render engines to see what you like and to troubleshoot for your project. It really depends on the project, the budget, the timeline, all of those things. What's the best fit? Are you doing a full animation? Are you just rendering a frame? And as a quick reminder, the nice thing about the photons is, again, you can, in our render settings, see that you can kind of cache these calculations a little bit in here and then just load them later on, which should improve the render speed. So that is a plus side of the photons, is that you have these different modes that you can work with in here to save yourself some time in the long run. There is one more setting that I'd like to cover real quick, unique to the photon caustics, and that is the trace depths. So you can think of this as the number of bounces that your photons are doing. So reflection, refraction, and combine. So this will cap these at a certain amount. So if you make this lower, your reflection and refraction will be capped at that. I kept these all the way up because I like more detail, but you can control the amount of detail in your caustics this way as well. As for something like a thumbnail, I felt like, or a single render, the brute force can be really nice because you're just rendering out one and you can throw more samples at it. This one actually it didn't take too long to render, and this is in 4K. And I think it's partially because of the way I had adjusted the lighting in here. So you can really play around with these two, and I hope you found this helpful. And if this helped you troubleshoot your project, please let me know in the comments and what you're working on. And if you'd like to join our Discord server or check out the membership to get help live in the Q&A session, you're welcome to check that out. I do have one-on-one coaching for Cinema 4D and Redshift, so if you're working on a project and you got stuck, I'm happy to help you out with it. And I'll see you here next time on Ambient 3D Animations.